6th. And our guest today is David Valeur, who is the founder and CEO of Green Taxi. Thank you very much for spending some time with us, David.
Addison, appreciate it. Looking forward to it.
So what we would like to probably get is some sort of introduction about yourself and Green Taxi.
Well, I've been involved with aviation pretty much my whole life, whole adult life. Learned to fly when I was 15, got my pilot's license when I was 16, and I was fortunate enough to, I call it, get my $35 million lottery ticket to fly F-16s for the Air Force, which was an amazing opportunity to serve our great nation and also to fly some of the best aircraft in the world. So that was a foundation for me before I purchased a company called Simplex Aerospace. It's now renamed or acquired by DART. And what Simplex makes is the firefighting kits that go on the belly of helicopters to drop water on forest fires worldwide. So the LA City fires that you saw, the tank systems fighting those fires, many of those were from my previous company, Simplex Aerospace. And so I've done about 25 US FAA certifications. So that background is what kind of was the genesis of having the experience for e-taxi. Approximately 10 years ago, I heard about another company that had come up with an idea for an e-taxi and ultimately did not invest in that company. However, it launched the idea of the value of e-taxi. So after I sold Simplex Aerospace to private equity, I started to do a lot of deep dive research on electric taxi, e-taxi, and why hadn't this been done before? Safran did a system that was demonstrated at Paris Air Show at 2012. In fact, the video is on my website. It works. Other companies have looked at this. And I came to the conclusion the challenge with e-taxi is not that the technology is feasible. It's the demands of getting it through the FAA certification. And there's three confluences of events that I think bring e-taxi to the forefront today. The first is net zero. The aviation industry is under the highest pressure it's ever had in the history of aviation for reduction of CO2 and other emissions. So the pressure is high. Amsterdam Airport is considering legislation to require what we've now trademarked, zero-engine taxi. California is thinking about that as well. So the pressure is very high. Fuel prices are another pressure point. At the same time, off-road and race car, F1 race car technology for hybrid vehicle components, billions of dollars have been invested in this area. So like I did with Simplex, we're leveraging the best of the best of these billions of dollars of R&D to develop our system that will be lightweight, reliable, proven to go on the main landing gear of the aircraft. And I think the third confluence that have really brought me to doing Green Taxi Aerospace is that the FAA, through the FAST, the FAST program, had a grant that they had a competition for. And we were very fortunate to receive a $5.6 million grant from the FAA last year, which is still in place. And that was the vote by the industry to say, okay, we're going to do this. And the FAA obviously did deep due diligence on my team, my background, the design, and the concept that it could be FAA certified before they allowed the grant. So that was the green light to really kick things off in high gear, late 2024, and now obviously to 2025.
So if you look at the e-taxi solution, you'd mentioned fuel. What do you think what are the benefits for an airline?
Yeah, we've got a number of airlines we're talking to right now, ranging from Delta Connections, SkyWest, Alaska Airlines, Horizon Airlines, who operate regional aircraft. And there's really several advantages. One is obviously the fuel burn itself. It's approximately 100,000 gallons of fuel per year per aircraft. Amazingly enough,
That's regional
5%,
aircraft you're talking about, right?
yeah, per aircraft per year. Correct. Yeah.
Regionals, though.
I'm sorry?
Regional jets, not mainline airplanes.
Correct, because the more you cycle the system on the ground, the more benefit you get for the savings. That's assuming a aircraft that turns 4.5 times per day. Long haul aircraft could use the system, but they turn about 2, 3 times a day. So their savings would be maybe closer to 80 or 90,000 gallons of fuel. But in general, it's around that 100,000 gallons of fuel per year per aircraft. Cerium, who's a large data analytics company, and working with us, we did an analysis of over 200,000 flights, and 5% to 20% of the fuel for the whole airliner flight is burned on the ground going from the terminal to the runway and back. So that's obviously the most low hanging fruit of benefit, along with 1,200 metric tons of CO2 per year per aircraft, which is around 2 to 300 vehicles, on-road vehicles of CO2 just for taxi operations. So another benefit is the brake savings. As a jet pilot, I know this from experience, but it's also well described in the literature. There's a thing called cold snubbing, and that occurs when carbon fiber brakes on a jet airliner are utilized when they're cold. An application of cold brakes at 3 miles an hour is actually worse than applying them at 120 miles an hour when they're warmed up. So, as a jet airline pilot, we have to taxi and use our brakes frequently, 30, sometimes 40 times per flight, because we have way too much thrust. It's like driving your car with the gas pedal halfway down. You're kind of dragging your brakes, so you have too much power coming out of the main jet engines. That's probably going to be $50,000 to $80,000 of savings per year in brake savings because we have slight regenerative braking, which means we can slow the aircraft down with our system. If they got to stop quickly, use your main brakes, of course. But that's another major savings is the brake savings. That's number two. Number three is the concept of foreign object damage. Jet airliners are like a big vacuum sweeper. They pick up debris, everything from a pop can to a quarter to a wrench, and they don't like that very much. So one foreign object damage every few years is millions of dollars. And because we're not we're not running the main engines during taxi operations, this will be significantly reduced. A corollary to this, there's actually an airworthiness directive out on this topic. In the Middle Eastern operations, they're sucking a lot of sand through their motors and through the compressor section of the jet engine. This is causing a glazing to occur on the fan blades as well as the compression section, which we would dramatically reduce as well because we're not sucking that sand during ground operations during that time. So foreign object damage will be number three. Number four, which is well demonstrated in the industry or well discussed in the industry, is the fact we don't have to use a tug. The aircraft from the gate is able to reverse from the gate using the auxiliary power unit from the jet power unit that's in the tail of the aircraft. No tugs required. There will be wing walkers. The standard operating procedures for all airlines are going to require wing walkers regardless of for safety, but we can back away from the gate and that saves the tug. But another major savings is about 3 to 5 minutes of what we call latency time. And latency time is where the jet is on the ramp, you're starting the engine or engines, you're waiting for the tug to disconnect, you're disconnecting the cord from the tug, and that 3 to 5 minutes can be saved now because we would be able to back away from the terminal and immediately start going down the taxiway without needing to wait for the disconnection of the tug and starting the engines. We would start the engines on the fly, literally. At the point where number two or three positioned for takeoff, we'd start number one and then number two, and then no longer use the e-taxi right prior to takeoff.
David, how long does this Where are you in terms of an SDC for this? How long does this approval process take?
Uh, well, that's always the question on the table, I think, for all design, engineering, and certification companies. The advantage we have is we've partnered with a company, Standard Aero, well-known $5 billion company, because another one of the companies I'd worked with before, Lumatech, recommended us use them because they have a thing called an ODA, an Organizational Delegated Authority Station. We had one at Simplex called a DAS, similar, but what it allows companies to do based upon the FAA extensive due diligence and trust, they're allowed to streamline and simplify the certification process, and they actually could issue the STC. So if you go through a standard STC process or FAA certification process, you have an engineer review your paperwork, submit it to the FAA, and then you have to wait for the FAA, which is incredibly burdened right now with a lot of very high important things they're working on right now. But you have to wait for the certification, the ACO, Aircraft Certification Office, to review the data and then get back to you. The ODA with Standard Aero, we believe will significantly streamline this process. It has in other projects. Our goal, and these are goals, and we try to under promise and over deliver. The goal is to have the drawing stack and the compliance checklist completed in approximately 1 year from now, which would be summertime of 2026, which will then allow us to do a thing called a conformity installation, where we install the conformed parts, the actual components, onto the aircraft and do testing, and that would occur in early 2027. And that's the time frame that we've agreed with Standard Aero as a reasonable time frame, with the goal of having the actual FA certification completed by end of 2027.
And what does this technology cost? And like, how did you, I guess, what's the trade-off? You've mentioned the amount of savings. What is this actually going to cost an airline per airplane?
Yep. So what we want to do is make sure the airline operator, our commitment and our promise is that they'll have at least a 50% return on their lease payments. So we've calculated the savings to be approximately $300,000 to $350,000 per year. Let's use 300,000 as an example. If they actually achieve a $300,000 savings, our lease payment is going to be, approximately 200,000, which will allow them to obviously pay back the lease payment of 200,000 plus make a profit of $100,000. We'll maintain the system. We'll make sure it's continuous airworthiness and all the things through an MRO system we'll have in place. But we want to make sure the airlines profit, and that's just on fuel savings. We're not including the brake savings and the FOD savings and the pushback savings in general in most of those calculations. So back to your question, we think the lease payments will be approximately $200,000 per year per aircraft. So there'll be no CapEx for the airlines, and they'll be able to put the systems on when we support them in that process.
Okay, so now you're putting this on the main gear.
Mm-hmm.
Is it on the inside wheel or the outside wheel?
That's a great question. So we had looked at the nose wheel, determined that's not a good approach, and Airbus and Embraer both agree that the nose wheel is not, in their opinion, in our opinion, not the preferred location. So we looked at, Safran had done the system on both main gear on the left and the right. And we've determined that we can do it on one of the outside wheels on one main gear. And a question that many people have is, well, but there's a potential that'll put a side load on the nose gear. And this is true. However, all the aircraft basically that we're looking at, all allow for single engine taxi operations, which the side load thrust of one engine, jet engine, is significantly more than the e-taxi will be. But to be specific, it's one tire on the main gear on the outside tire of the main landing gear of the aircraft.
So not both gear, just one gear has a motor.
Correct. Yep, it
Okay.
saves weight. The other systems that have been out, the Safran system, and this is per their press releases years ago, was around 700-ish, maybe to 1,000 pound weight. The motor controller was on a pallet, literally. Our system is going to be below 300 pounds, and our motor inverter that drives the motor, instead of being on a pallet, electronics have gotten so much better. Our inverter is approximately 2 feet by a foot thick, so it's significantly lighter and smaller because again of the billions of dollars that have gone into hybrid vehicle technology that we're leveraging the best of the best for.
And what do you expect this motor's well, the motor's going to take a hammering with every landing, right?
Mhm. Well, that's actually one of the most critical paths of the design is that we have to make sure that the motor and gear train are 100% disengaged from the main wheel when the aircraft lands. It won't like having it self-run at 10 times the RPM of the goal. The system is certified, will be certified to 25 knots, but you land the aircraft at, let's say, 125 knots. You want to make sure the system's disconnected 100%. But continuing with your question, Addison, um, there will be an impact load when the aircraft touches down, but the motor won't be in operation. So that's called a static load, a non-operational load. And we just had that conversation with our motor manufacturing team, and we don't see that to be a problem with the static motor not operating because the bearings and the shaft and the motor shaft will tolerate the impact of landing without any concerns at this point.
David, you said there's one motor on one main gear. Is that on the outside of the wheel? Or I mean, what are you going to do with brakes? Because brakes generate a staggering amount of heat,
Yep,
even if they're carbon.
agreed. And that's kind of one of our secret sauces. And again, I'm not too concerned to show, so we'll have some renderings on our website in the months ahead. Uh, the secret to our solution is we utilize the existing wheel assembly. Why is that important? Well, Meggitt and other Parker Hannifin and other large conglomerates who have created wheel assemblies know that that's millions and millions of dollars of development work. Also, the airlines don't want to have a supply chain where they have to use a different wheel if they use the e-taxi. So on the wheel assembly is a lug. These lugs are used to hold the brakes in place, and the brakes push on these lugs. So our sprocket ring gear attaches to the existing main gear wheel assembly lugs. I can show you pictures of that, but that's how it works.
So it's on the inside between the tires.
Affirmative. Inside between the tires, the motor is laterally parallel to the ground. Space is tight, and that's why we've had to leverage so much high technology and why this is all proprietary. And we'll have exclusives with all of our vendors because getting the space to get, we have approximately 50 kW, which is a 50,000 watts of power available from the APU, approximately. We have more than that, but the aircraft draws power on its own for the galley and the avionics and those type of things, which we have to take into consideration during our electrical loads analysis, ELA analysis. But to answer your question, yes, the motor, gear train, sprocket all fit between the main landing gear tires and then drive the existing main landing gear wheel assembly with a sprocket that's mounted to that main wheel assembly. Yes.
It'll be fascinating to take a look at that when it's available. You mentioned that you were going to do a lease. Can you walk us through the business model?
Sure. We looked at this. The airlines are really used to leasing equipment now. Many of them lease their engines. Some of them lease their whole airframe. The airlines, many of them, have optimized to not be capital extensive companies, although they still have a lot of capex, but they really like to be operators. So we want to share in the savings and not have to have a large non-recurring cost day one for our systems. We want to have it spread over time. It benefits the airline from a CapEx standpoint. Obviously, we get a share in the ongoing operational use of the system. All the airplane we're working on now, we think will be in the industry for God, probably 20 years, especially narrow body and regional jets. As we all know, even the ERJs and the CRJs, super high demand because there's nothing else coming out right now on the drawing board. So about a 20-year life for our system, and we be able to share that with the airlines as well as maintain it, and the lease really reduces their costs up front and make sure that we're all engaged together to keep it efficient and making sure it's working effectively over the 20-year life of the system.
Okay, my last question then, David, is you mentioned some airline names. Can you give us a sense of those conversations and what's the reaction? Where do you think this is going to be going?
Yeah, it's been amazing the support we've received. Unfortunately, because e-taxi has been thought about before, and there's been people that have tried it before, but nothing's come to actually fruition on the aircraft in a certified fashion as of yet. There's initially some reluctance openly. We had to kind of show people, including the FAA for our FAST grant, that we're different. And we are different because every step along the way, we only look at things that can get certified. Can't get certified, this whole idea goes up in smoke. It's got to be certified. So when we first approached one large major airline, it's taken almost 2.5 years and probably 100 emails and 4 or 5 trips to their corporate headquarters to get them where they've now in a position. We've got a partnership agreement in place. That will be several weeks from now. We will have a major press release on who that's going to be, but we can't share that as of right now. The ones I've mentioned, though, all of them are providing engineering and design ideas because even the pilot control system, how does it interface with the pilot? Where we mount the gearbox, is that fitting used for other functions? Electrical loads analysis, what type of power are these on the aircraft? All of these dialogues have to be extensively reviewed with the airlines so we can make sure that it meets their operation requirements. But to be specific, Delta and Delta Connection have supported our design work. SkyWest is extremely helpful, very proactive company and airline, as well as Alaska and Horizon. We've had several conversations with them, and they've given us great insight from an operating standpoint. And again, I think the other thing we've done maybe differently, we haven't really started a major marketing push yet because, again, under promise, over deliver. We wanted to make sure that the technology and the concepts were far enough along to where we knew we were going to get this done before we went to the marketplace, which is where we are now. We've overcome really all the major technical hurdles. They're being refined. But for example, does the APU have enough power? That's a major technical hurdle. If you don't have enough power to operate the system, this whole thing goes away. We've shown that, yeah, a top speed of upwards of 25 knots. Steady state will be below that, probably around 16 knots, but that's achievable with the power. Is there enough space? We've determined it's tight, but with the technology we've leveraged, yes, there is space. Is the disengagement mechanism reasonable to disengage? Is the FAA certification process? What FAA regulations do we have to go through? We've narrowed that down. In fact, we just finished our call with Standard Aero here half an hour ago, and we're going to be working through our compliance checklist and our conformity plan, and that's going to be in the next several months. We'll have that completed. So the technical risks have been identified and worked through to where we're confident to now go out to other airlines besides the ones we've mentioned to say, yep, we're going to do e-taxi, and we're really excited about doing that.
Well, David, thank you very much.
Great. Thanks, Addison. I appreciate it very much and appreciate what you're doing with the industry to keep people informed about what's going on. That one last thing I want to close with, I think another reason why we're so excited about e-taxi, as you look at SAF, sustainable aviation fuel. You look at hydrogen aircraft, and you look at electric aircraft, all very interesting ideas. Billions of dollars have been poured into those. And of course, let's look at all the options. But those specifically, most of those are at least a decade away, maybe 2 decades away, especially for clean sheet aircraft designs. And this technology can be implemented and certified on the airlines in under 5 years. And I think that's why the FAA did give us a very large grant, because they saw that this was a way to significantly move the needle towards net zero goals and fuel savings in an under a decade period of time, which is, we're excited to be part of that, to helping the industry and really revolutionizing taxi operations with zero engine taxi.
Fantastic. Well, best of luck.
Thank you, Addison. Appreciate it.